carefully. So did you get chance to practice yesterday's class, everyone? Please confirm. I'll wait, please.
Yes,
Yes.
sir.
Others,
Yes, sir.
Yes, sir.
fine. Others, let me know, please.
Sir, one
Others,
question.
tell me, sir. Please tell me. Yes.
So yesterday I have done the practice and I have make sure that SQL also connected with SQL authentication. But later when I am trying to pause the pool, I cannot see the pool in my all resources at all.
So did you configure the pool?
Yeah. Inside SQL Server, I can see the pool and database also.
Inside SQL Server is the pool. I mean, from SSMS you are talking about, right?
Yeah. Yes. I am talking about SSMH, correct.
Okay. But you don't see it in the all resources, you mean here?
Yes, sir, correct.
Okay. Just remind me after the class today, okay? I'll come to your screen. We'll check it.
Yeah, sure, sir. Oh, thank you.
Okay. In general, if we see such problems, then in such a case, we need to try this one also. Manage view, show hidden types. Just like sometimes it works, Sometimes it automatically gets hidden. Show hidden types. This one. Okay. Just give it a try with this one. Hidden types. If not, just let me know after the class today. I'll come to your screen. We'll check it.
Hey Sai, this is Srikanth here.
Srikanth, tell me please. Yeah.
So if you don't mind, so can you record the session going forward, because sometimes we may miss some logic or some kind of this kind of an issues, right? So as far as it's very easy to refer back.
Technically speaking, not possible from my end. If you want, you can do from your end with whatever tools you wanted. Yes. Oh.
Sure.
Please.
I'll try.
Yeah, let me give the reason for it. We have the same webinar license for other trainers who are into corporate trainings. So it will be a problem for us, Again, there will be conflict with the webinar and other things. So we cannot do it. Yeah, because I'm not the only one at SQL School who provide training actually to other trainers, the same webinar ID. Yes.
Sure, no problem. Yeah.
Please, you may do from your end if you wanted to. But one thing, brother, whatever, like examples we do, the complete transcript in Word document, okay? So I'll make sure we are not.
Yeah, that's okay. I'm pretty much comfortable with the documentation, but sometimes, so that scenarios so just not
Yes, I got it. Maybe you can just, record from your end if you wanted to, okay?
Yeah, sure.
Thank you. Yeah. Yes, friends. We'll start our session now. We'll go for questions, if any, after the class. Okay. Any questions or clarifications or errors pertaining to yesterday's class, we'll do them after the class today. Let's get started. So yesterday we are talking about how to configure the Synapse. Let's understand an interesting and easier operation with Synapse. Storage, imports today. Later comes the concept of exports. Hope you are ready with your running notes, everyone, please. Yes, mic with everyone, please.
Yes, sir.
Yes, others, please.
Yes, sir.
Fine. So here we are, right? Yesterday's class. You remember one SQL pool and one database from SSMS, and here is the SQL pool. We paused it. Yes, hope you remember yesterday. We paused that pool, right? Yesterday's class. Yes, hope you remember. We paused it.
Yes, sir.
Yes, let me resume the pool. Let's continue our session now. Please make sure we maintain our own observation notes. Safe side, please. Let's do it carefully. let's understand simple terms, okay? Let me resume the pool. This resuming of the pool would take somewhere
కృష్ణ
between
సౌండ్ తగ్గించిన
2 to 3 minutes.
ప్లీజ్.
Let's understand how to perform the storage operations and data import operations with SQL pool. I'll mail you one .SQL script. I'll mail you one .SQL script. Let's wait. That script contains the information about table creations. Okay, table creations and data inserts monitoring activities. Let's wait for a few moments. Still paused. Still it is paused. Let's wait. In the meantime, let's understand. Azure SQL DW or SQL pool stores data in the form of tables. Remember that. Just like a regular database, here also we need to work with something called tables. An index is mandatory. Second point on the screen, index is mandatory for every table to store and access the data. Not only for data storage, even for data access also we require index. During the table creation, if we don't specify any index, we are going to see how to create tables now. We'll do it. During the table creation, if we don't specify any index, then it's auto-created. One clustered column store index is auto-created. Column store index, such index that stores unique values of the column. That is the main property of any data warehouse. What do we mean by unique values of a column? For example, assume you have a database, a table called, for example, product database and product table. Let's put this way. Let me show you here. I'll mail you one sample database for our practice next. Assume a table called customer data table. In this table, you see many customers have common gender male.
ఒక టేబుల్లో
If it
ప్రైమరీ
is
కీ
regular
లేకపోతే ఇండెక్స్ క్రియేట్ అవుతుందా
OLTP database system,
ఒరకిల్లో.
this value male or M is stored multiple times. F is also stored multiple times.
మరి ఇప్పుడు
Same way
చెప్తున్నాడు
marital
డిఫాల్ట్ ఒక
status.
ఇండెక్స్ క్రియేట్ అవుతుందని.
M means married, S means single. They are stored multiple times, once for each row. We call it as row
అది వేరు ఇది
store.
వేరు, కాకపోతే
Other technology
ఒక రకంగా అదే అనుకోండి.
introduced by
కాకపోతే
SAP
ఇప్పుడు నాకు
HANA
ఐడియా
about
వస్తుంది.
15 years back.
నేను క్రియేట్ అవ్వదని చెప్పాను.
Column store being used by any data warehouse now. Every data warehouse, right from Amazon Redshift to Azure Synapse to Snowflake, everywhere. Column store. In row store, every row is stored individually. For example, you are a bank customer, I am a bank customer. You and me are roommates. Assume for time being. Our address is same. Assume our gender is same. Assume our nationality is same. And only name and mobile number and email address are changing. Our company. Say we are colleagues, we are roommates. Almost all data is same. Only some data is changing. name, mobile number, email address, and employee ID. The remaining activities are same. Assume, like right from account type to account branch, home office, branch office, everything are same because we joined together in a campus interview. And the company made us to open a bank account, salary account in the premises itself, bank within the office premises. But the row is stored individually, right? So there is a possibility of redundant data. Multiple customers, same marital status, but repeatedly stored. Column store only unique column values are stored. Your gender, my gender are same. Our gender is stored only once and referenced multiple times. So index mandatory. This is a concept. Why index mandatory? Linking activities. Easy hyperlinking from one value to respective row. Value is M. Matter status M. Married. That has to be indexed with all customers who got married or whose status is M as per the data entry. Friends, hope you got some idea now. Column store, row store. Got some idea, everyone? Difference? Yes. Please.
Yes.
Others, limited response. No worries. Please try to respond to the questions, okay? We continue. Well, here it is. I'll say types of data storage. More response, more bias, less response, less bias. Because the intention to make sure whatever we understand is clear and simple. More we respond, more points we can have, right? Isn't it? Because yes, we are in a comfort zone. Otherwise, no. Too many points, it may cause something else. So let's resolve the things carefully. Depends. Your learning, your response, your hands. I'll continue. Azure DW does not support foreign keys. Not required. Not support foreign keys. Not required because all validations will be taken care by option 1, regular OLTP, option 2, ETL. We'll do the validations. No support for secondary data files nor secondary log files if you are comparing with regular SQL database concepts. Just in case, this line is in case if you started to compare with regular SQL database. No support for secondary data files nor log files. Instead, we have something called internal file stream files. Friends, any idea file stream files? File stream.
No.
No, sir.
No problem. Please see if you can revise SQL Server installation concept. In SQL Server installation, regular installation process, you come across something called file stream. This one. Please see if we can revise SQL Server installation. You come across something called file stream. Purpose for big data storage and analytics. For Azure Cloud, it is required. Remember the term file stream. Well, back to our screen once again. Does not support foreign keys. Well, I'll modify the notes to make it more simple for easy understanding them. No support for foreign keys. and no space restrictions, unlimited data stored in file stream format. To manage this format, we have nice commands from today we'll do. And Synapse allows or follows massively parallel processing architecture. Every table involves three properties: partitions, distributions, max DOP. Our agenda today to create tables, insert data, and also import data from other sources from today. So for that we are understanding the base concept, the architecture part. Every table involves partitions. A criteria to physically divide the table data into multiple storage areas within the warehouse. And distribution. Logically arrange the table data within each partition. How to understand? Simple terms. Assume a class of boys and girls. Partition based on gender. All boys made to sit at one side and girls on the other side. Naturally, to my experience. Within boys partition, seating arrangement distributed based on roll numbers or grades, something like that. My PT master used to make us sit in height wise. All boys, one partition, all girls, another partition. Within each partition, again, distribution, seating arrangement. My PT master used to say height wise. My English madam used to say roll number. Depends. That arrangement within the partition is called distribution. Why we are learning this? Reason. During the creation of tables, today we need to have something like this: distribution, partition. Okay? Keeping these examples in mind, we are taking the fundamental definitions here. Hope you got some basic idea now, everyone, to start our practice. Criteria for physical partition, logical arrangement within the partition, distribution. Got it now? Please confirm. Got some basic idea, everyone, please?
Yes, sir.
Yes.
Fine. Yes. Let's continue. Please, okay, we'll slowly change the levels of information based on our response rate. Please, let's cooperate. Let's do it carefully. Partition types. These partition types, two types we need to work with: right and left. What are these? We'll take them now, today, with examples slowly. And please take your mind, please. And distribution types also, there are three distribution types. Round robin distribution, this one. Round robin distribution has distribution replicate distribution type. Round robin means something like this. First few rows will go to one distribution, whichever rows were inserted first. Next row inserts next distribution, and so on, up to 60 distributions per table. As per the Synapse architecture, up to 60 distribution, 60 allocation units are possible. We have something called hash. Distribution occurs based on a given column value. For example, based on roll number, based on height, something like that. We define specific column based on which distribution of data occurs within each partition. For example, based on employee ID, all employees 1 to 100, one distribution, 101 to 200, other distribution, so on. Then we have something called replicate. Every row is duplicated to multiple locations. Minor sound, right? Isn't it? Please, please. Siva, I'll mute you, brother, for some time, please. We'll go for questions after some time. Please. Let's continue where we are. Replicate. Every row is duplicated to multiple locations. Observe carefully. Okay, so here we go. In replicated tables, a table is given to multiple distributions like this.